Algebra 1. So this is Algebra 1. We do notes today. So notes, section 3.3, function notation. All right, you can put your name up here, date, period. So we're going to take some notes and write these all down and upload them for credit. And then we'll do moderate in progress today. So let's talk about what function notation is. So function notation is another name for y. It's like kind of a fancier way of writing name for y. So, for instance, we're used to the equations being like y equals mx plus b. But now we're going to write f of x equals mx plus b. So instead of y, we write f of x. Now that's the way you say f of x. So x is the input, which is the thing that we always see over here. But now we're going to actually show what we're plugging in here. And y is the output, or f is the output. So that's like the y value. So it's kind of like what we've been doing, just with a little more detail. So like if you had y equals 2x plus 1, function notation would be like fx equals 2x plus 1. Now they like f is a common name because f for function, but it could be any letter, G, A, B, but f is pretty common. So that's what function notation is. So let's look at some examples using it. So example 1. We're going to look at evaluating function notation. Evaluating. So you're going to be given a function, let's say, for instance, negative 4x plus 7, and you want to evaluate it when x equals 2 and x equals negative 2. So this is like two separate problems, two plugged in. So they're giving you the x's, and we want to get the y's out like we've done before. But the way you write it here is now we're going to say f of 2. So we put the thing that we're going to plug in here. No math is happening up here. This is saying the y value when x is 2. There's no math to do that. This is where we're going to do the math. So we're going to substitute 2 in wherever we see an x. I put it in parentheses. So we're replacing the x with 2. And this is the way I want you to show your work. Keep writing the f of 2 on the left. Over here, you got to do PIMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So you got to do negative 4 times 2 first is negative 8. And then we're at f of 2. And negative 8 plus 7 is negative 1. And that's your answer, including the f of 2. Okay? Because this has a lot of information. This is saying when x equals 2, y equals negative 1. When we put 2 in, we get negative 1 out. So we can do another one with negative 2. So same thing. We're going to rewrite the equation exactly as it is, and wherever we see an x, put parentheses negative 2. Always put it in parentheses. That'll help remind you that this is multiplication, right? Negative 4 times negative 2 is positive 8. Negative times negative is positive. And 8 plus 7 is 15. So f of negative 2 is 15. When you plug in negative 2, you get 15 out. So that's just evaluating it. We'll look at sort of like some application example right here. Interpreting function notation. So this is kind of like applied to some kind of like word problem. So the problem might be f of t. So we don't always have to use x. A lot of times we use variables that kind of are related to what real world example we're talking about. F of t is the outside temperature t hours after 6 a.m. So T doesn't stand for temperature, T stands for time. function is going to give you temperature. Explain the meaning. Okay, so t hours after 6 a.m. means like if t equals 1, that's not 1 a.m., that's 7 a.m. because it's like time starting at 6 a.m. So here's an example. F of 0 equals 58. So you're not even being asked to do any calculations here. You're just being asked to explain what this means, like in the problem. Now, what's getting plugged in is the time, and what's coming out is the temperature, right? So this is saying, so the temperature is a function of time. Based off what time it is, you'll figure out what temperature it is. The later it gets in the day, probably the warmer it gets up until a certain point. So the way we would say this is we'd say, we were going to write a little sentence. Temp at 6 a.m. Now, I know it's 6 a.m. because 0 times since 6 a.m. So at 6 a.m. Is 58 degrees. So that's the interpretation of what they gave us. Let's do one a little more interesting. F of 3 is less than F of 9. So this is 3 hours after 6 a.m. So that's going to be 9 a.m., right? We're talking about 9 a.m. 9 hours after 6 a.m. is going to be 3 p.m., right? And saying the temperature at 9 a.m. is less than the temperature at 3 p.m. It's colder, whatever. So we might say something like this. Temp at 9 a.m. is less than temp at 3 p.m. I mean, you could even say temperature at 9 a.m. is colder than the temperature at 3 p.m. That might even be like more interpretation. So that's what we're talking about there. Let's look at another example. Example 3, solving for the independent variable. Now, we've talked about this in previous lessons, independent, dependent. The independent variable doesn't depend on anything. So does x depend on something or not depend on anything? Does y depend on something or not depend on anything? So generally, the independent variable is usually x. It's or what's being plugged in because we can pick whatever we want. And the dependent variable is the one that depends on it. So here's a problem. H of x, see, it doesn't always have to be f. It can be, say, h equals 2/3 x minus 5. Find the value of x when hx equals -7. So this is like they're giving you the answer, and they want you to figure out what to put in to get that answer, right? So this is kind of saying like if y equals -7, what is x? So we're trying to go backwards. So what we can do is we say, well, we have this formula that'll, if we put an x in, gives us the y, but we know the y, so let's plug that in. Let's substitute that in for h of x. Let's replace it with -7. We know that h of x equals -7. We don't know what x is, but now we can solve this equation. Like back in chapter 1, we solved equations, multi-step equations. So now we just got to do some work like we did from chapter 1. Get rid of addition and subtraction first. To get rid of a subtraction, you got to add, right? Reverse PEMDAS. -2 equals 2/3 x. Then we got rid of addition and subtraction. Now we should get rid of multiplication and division. I personally would get rid of the denominator first, which is division by multiplying by 3. Both sides do the same thing. And then last, divide by 2. So I would put the answer as at x equals -3. Usually we like to put it on the left side when we're finish for a final answer. It doesn't really matter in your work what side it's on. But so that's what you would do if you're trying to solve for the independent variable. You're trying to find the value of x of y. Back on example 1, you were given x and found y. Now we're given y and find x. So it's just backwards. Okay, example 4, our last example. Graphing. So you're going to be given a function, say f of x equals 2x plus 5, and we're going to graph it. And what we're going to do is we're going to make a table, and we're going to do at least 3 points. So let's say -1, 0, 1. I'm spacing them out because I'm going to show a little bit of work here, because I'm going to want to see your guys' work too, and it's just nicer to put it in the table. At least 3, I would say at least a negative, at least a positive. A -1 and positive 1 are pretty simple, negatives and positive. I'd say at least 0, because that's a nice one, and it's also super easy to calculate usually, because 0 times things, 0 plus things is usually pretty simple. So let's show our work like we did back on example 1 here. So we plug -1 in. We get that. Row of operations. So there we go, we get that. And I'm going to do F0. So I want to see this work. 2 times 0 is 0. 0 plus 5 is 5. So these are the y values right here. Okay, f of 1, last one. 2 times 1 plus 5. Multiplication and division first. 2 times 1 is 2. Addition and subtraction last. 2 plus 5 is 7. So that's the y value. So I need to see the work, go to the table, and now we're going to make a graph. Now you could use graph paper, or just got to draw these as nicely as you can. I already kind of know what the values are. Like the x values are -1, 0, and 1, so I don't need much more room on the graph left to right. The y values are 3, 5, and 7, so I need more room up here. 1, 2, 3, 4, 5, 6, 7. So -1 to the left, up 1, 2, 3. So when you graph the x first, you go left to right, negatives to the left, line it up with -1 on the x-axis, and then go up to 3 on the y-axis. And 0, 5, don't go left to right, up 1, 2, 3, 4, 5. Right, the y value is 5. And then 1, up 7. 1, 2, 3, 4, 5, 6, 7. And then this should be a straight line, right? It should be linear. I mean, that equation looks like y equals mx plus b, right? You get just something straight, ruler, or just something. And this is a continuous function. We talked about continuous discrete, because you can plug fractions in here if you want. We just chose some values. Put some arrows on the ends, so that shows it keeps going. Now we know this is a linear function based off the picture, based off the equation, based off the table. It has a constant rate of change. From here to here it's +2. From here to here it's +2. From here to here it's +1. From here to here it's +1. So it has to have a constant rate change. The x is changed by the same amount every time. The y is changed by the same amount every time. So it's not surprising that it's a linear function, right? Linear function, constant rate of change, y equals mx plus b. That's it for the example. So for today, your classwork, you're going to do monitoring progress problems 1 through 12 all. They start on page 122. They're at the bottoms of the pages. Write them down on a separate sheet of paper, show all your work, box your answers. If you're doing it on the student dynamic eBook, use little blue arrows for each problem. That, if you play, shows a video that shows you how to do the problems, so no excuse. When you're finished, you will need to turn in your notes, and you also need to turn in your monitoring progress to get full credit for participation today. So that's it. You can check out the other video I have in the lesson and try these today.